The rate of reaction can be monitored by observing changes in the mass, volume, or concentration of reactants or products. If a reaction produces gas, you can measure the volume of gas produced via displacement of water or gas syringe. With displacement of water, as a gas is produced, it fills the upside-down measuring cylinder and forces the water out. With the second method, the syringe expands as it fills with the gas that is produced. The gas syringe is the better option when a water-soluble gas is being produced, as the product will not be lost in the water. Measuring the change of mass of a reactant can be a useful method when gas is produced, as the purpose here is also to determine how much gas product is produced via the change in mass of the reactants. The cotton wool plug is important to allow gas to escape. This should not be drawn as a stopper, as that would prevent gas escaping. Gases that are less dense than air can be measured using upward displacement of air, because the gas produced is lighter than air, so it will move upwards for collection. This has a similar principle to the displacement of water, as the gas product pushes air out of the collection tube. For gases that are denser than air, downward displacement of air can be used, as the gas product will travel downwards. It's important to draw stopper lines that are not over tubes and scales on measuring cylinders and the syringe. The rate of a reaction as it progresses can be visualized as a graph. Here it is important to know the quantity of product produced or reactant used, as these values go on the y-axis with the corresponding time on the x-axis. Reaction rate decreases as it progresses, which is seen by the gradient or steepness in the line at points 1 and 2. At 1, the line is steeper, so the reaction has a greater rate than at 2 when the line is less steep. The rate is greater at the beginning of a reaction because the largest quantity of reactants is present at the start. As the reaction progresses, the reactants are used up and the rate decreases until the end point where the reactants have been completely used up. At the end point, the line becomes horizontal. This indicates that no more products are being produced.